So we did not investigate the flow pattern, unfortunately, but if there is a change in flow, that might be a possible explanation maybe why realignment occurs.
We might want to look into if there's a difference between upstream and downstream regions.
Yes, exactly.
That would give us a clue.
Yeah.
Okay, thank you. Thank you, Eric.
Thank you. Apart from chairing this session, I also have the honor and pleasure to have a short discussion with you about your work, and of course also my compliments with the writing this thesis, and also my compliments go to your first promoter, your co-promoter, especially because it's a nice combination of experimental and computational work with somebody that's promoting it as computational scientist, like myself are, and computational work that I like very much, of course. So, but of course I have some questions. Looking at your computational modeling, then I look at chapter 2 and see in the inverse finite element analysis methods that you also describe in chapter 4. And specifically on page 28, you give a description of what you consider the stress tensor. And the stress tensor affected two contributions. One you call, say, the isotropic contribution, the other one is called anisotropic contribution. Apparently, the whole presentation today also we said anisotropy is very important. So you would expect also, if you look at the stress tensor, that the isotope term is small and the isotope term is large. And then I looked at your whole thesis, but I never see which of the two terms are indeed smaller than the other one. Is it true or not?
So, yes, hi, you learned opponent or chairman. We had a look, basically what I've seen is that the mechanical properties of what we said, the Young's modulus for the neo-Hookean model, which we assume for the isotropic part, we have seen that Young's modulus is for the so-called matrix stiffness, which is not the collagen fibers, was significantly lower than the mechanical properties, the fiber stiffness, which is the parameter in the anisotropic part. And based on that, we think that the collagen fibers are the most load-bearing structure, and then combined with what we have found that there's a high alignment, we do believe that the anisotropic part does play a major role.
Okay, so let's zoom in indeed on the anisotropic term. I try to understand it. Now, I have some small technical questions about that, but let me zoom in. Especially because I saw a new formula for myself. Of course, I know about Gaussian distribution, non-distribution, but I've never seen a periodic version of it. And when I this morning downloaded the page you're referring to from both Kasser and from Driessen, I was happy to see that note in the previous studies, the normal probability or Gaussian function was used. You were the first one apparently to use the periodic version of one. And I try to understand what you're writing there. Of course, I see the cosine and I understand the factor capital A, I also understand the alpha, but now the beta you call at some point the fiber distribution, but in fact later on you say this the dispersion term. I think you also mean the dispersion term. What I'm a little bit surprised by, you say when beta was 0.7, you call it rather anisotropic. If I go to chapter 4, then I look at different tables, and I look at beta, and I see instead of 0.7 also factors like 8.1. Should I call it extremely anisotropic then, or how should I interpret it?
This value was is also relative value, and we have basically there is a stronger fiber alignment if it's basically if we choose our base value to determine, okay, this is rather isotropic, and the other higher values than that is
The alpha is the mean direction and the beta is the square.
Yes, that's
suggestion there. So the larger beta is, say, the more heterogeneous, you could say that. Understand that, but more specifically, in fact, what I don't understand in the formulas in general is if you look at different parameters, it's a rather complex formula, you have many different contributions, you never use something like it's called the sensitivity analysis. So if you say if beta is 1 or beta is 10, what kind of difference that might give on your stress tensor? Could you comment on that?
Yes, this is a good point. So this has been already done by my predecessor. He conducted a sensitivity analysis, and he has basically shown that it's possible to always find a global minimum using changing different parameters.
Yeah, but that is, why should you look for a global minimum then? Because in general you could say it's a dynamic system. why should you look at a stable situation?
I'm not sure I know what you mean.
If you do analysis, you try to minimize things. You
Yes,
say
of
later
course.
on, if you say, if you look at the tables in chapter 4, you say when the difference is larger than 30%, then I consider this, so you're looking at something, apparently you're optimizing something.
Yes.
And the question, of course, is what exactly are you optimizing?
We optimize the error between the experimental result and the simulation.
Then you also would expect something indeed, if you look at the error, you see some kind of, say, standard deviation or error analysis, and that's something I'm missing in your thesis. Yeah? But let me go to the more general question then. You're advocating, in fact, patient-specific modeling. We used it several times already today. And my question, in fact, is what, if you now, similar like Professor Dahmer was stating, if you say at the end now, look at what should that patient-specific model be in terms of, if you look at my colleague Steigers, he said look at the weakest part. So you could also use something like some kind of staining method to find out certain areas, and it might be the weakest part or something like that. Is that, should that be included in your patient-specific model, or what would you comment on that?
Looking at the weakest part is of course interesting because it's the weakest location which might be most likely to rupture. The problem is the heterogeneity of the tissue. So we have shown, for instance, I think that the problem is that we're not always sure, is the weakest part always the part which is going to rupture? Because if you look at the stress distributions in models, you can see that very locally stress peaks can occur. And those stress peaks might not occur at the weakest location of the tissue. And that even locations where the tissue is more stable, that even at those locations, due to concentrated stresses, that those locations also might rupture.
Okay. Now, apart from the first motor, we also have a co-motor, and we have 5 minutes left, so I will give him also the possibility to have some discussion with you.
Thank you. Geachte promovendus, dear Chen-Ket, you are confusing me considerably today, in the last 15 minutes. I would like to go with you to page 105. Of course, we've seen that the material is very heterogeneous. The stresses that you find are all over the place, stiffness is all over the place. The spread in data is huge. So I remember us sitting at a table discussing all your data and also looking at the tests from Carlijn Groene, where we looked at ultimate strains and stresses. And then we found, we looked at figure 7.1 at page 105. And one of the things we noticed was that the ultimate strain varies between, say, 0.25 and 2, which is not a factor of 100 or 1,000 that you see in the stresses. And also it seems, not only in your own studies, but also in the studies from Laurie, Lennon, Holzapfel, Mulvihiel, that there seems to be a lower strain level, which, if I look at that figure, is something around 0.25. And I remember that the first promoter was suggesting maybe we should look more at strains than at stresses, because strains are easy to measure, relatively easy to measure. You don't need a model for that, you can measure them directly. So maybe the real solution would be just to look at strains and make sure that we stay below a certain threshold of that strain. Well, you thought that a nice idea, so you put it in the discussion. And I already noticed when reading again the thesis that when I arrived at 7.33 that you write it in the thesis, but it looks like you don't believe it, because in 106 you go back to stresses and strains. And in the entire discussion today, when people challenged you to talk about a new solution, you didn't mention it. I was afraid that you were going to mention it because I couldn't ask the question, but now I do ask the question. Do you believe that looking at strains might be a way out of this mess?
Most co-promoter. Thank you for your question. So, well, sorry that I look like that I'm not supporting the idea.
Oh, you don't have to excuse yourself.
So I do think that this might be a possible solution, or what I would say then is possible shortcut through like a surrogate marker for looking at the indicator for plaque rupture. But I also do believe that there are other methods which also might be able. The problem again is, I think the real problem is that we don't understand why plaque rupture occurs, and that we need more understanding, and that we might need more understanding in that direction. And then, if we know what happens, then we have a kind of indication where actually to look at, in which direction to look at.
Yeah, but if I look at these data, why would I want to know what it is? If I know that there is a threshold at 0.2, what the heck? What does it matter that I don't know how it, why it? As long as I know that if I stay below 0.2, I'm safe, then I think the doctor will be happy. His knowledge. So yeah. So what is the problem if I wanted to do that? What problem do you think I will have if I focus on strains alone? Apart from not knowing what's going on.
Yeah, that's the problem. I think it's important to know what's happening, because of course you can use it at least for, you know, in between. It might be a very useful method to look at plaque stability. But I do think let's say I'm a bit more afraid that if we don't really understand what is happening, then that there will always be exceptions, and that if you just set this strict criteria, like the same is what people currently use. They say like stenosis 70 degrees, we do surgery. I don't really, and I dislike that idea to be so bold.
At least you give the answer of a scientist.
That means that exactly 1 hour has passed at the beginning of the session, so may I ask you here to comments to turn to the sheets. The session is adjourned.